Dry methane is supplied by a compressor and pre-cooling system to the cooler of a lean liquid methane system at 180 bar and 300 Kelvin. The low-pressure methane leaves the cooler at a temperature 6 degrees Celsius lower than the temperature of the incoming high-pressure methane. The separator operates at 1 bar and the product is the saturated liquid at this pressure. What is the maximum fraction of the methane entering the cooler that can be liquefied? Paris Chemical Engineer's Handbook is the source of data for methane. For the given, we have T4, which is equal to 300 Kelvin, P4, which is equal to 180 bar. For T15, we have to subtract 6 from T4, which is 300 Kelvin, since the methane leaving the cooler is 6 degrees Celsius lower than the incoming methane, and from that, we will obtain 294 Kelvin. P8 is equal to P9 is equal to P10 is equal to P15, which is equal to 1 bar. And for this problem, we are asked to find for the value of Z. For the equation, we have Z is equal to X multiplied by the quantity of H12 minus H5 plus H4 minus H15 all over H9 minus H15. Since we are using the Lindt process, X is equal to 0. The equation then reduces to Z is equal to H4 minus H15 all over H9 minus H15. For the values of enthalpies, we will be using the interpolation method, and the Paris Handbook 7th edition will be used as a source of data. For H4 at 300 Kelvin and 180 bar, interpolate between 150 bar and 200 bar using Table 2-282, Properties of Superheated Methane. We will then obtain the value of H4 equal to 1033.52 kilojoules per kilogram. For H15 at 294 Kelvin and 1 bar, we will be using the same table. Interpolate between 250 and 300 Kelvin. We will then obtain the value of H15, which is equal to 1186.672 kilojoules per kilogram. For H9 at 1 bar, for saturated liquid, we will use Table 2-281, Properties of Saturated Methane. Interpolate between 0.884 and 1.325 bar. We will then obtain the value of H9 equal to 284.7295 kilojoules per kilogram. Since we already have the values of H4, H15, and H9, we can now substitute these values to the equation and solve for the values of Z. Z is equal to 1033.52 minus 1186.672 all over 284.7295 minus 1186.672, and the final answer is Z is equal to 0.17.